Okay, so for 2.1, we're looking at functions. So first off, definition of a function. A function is a rule that assigns each element x in a set A to exactly one element called f of x in a set B. So the easier way to think of this is every input has only one output, or every x only has one y that goes with it. So for your domain, that's going to be your x values. Your range is your f of x values. A lot of times we also see our range as the y values. So when we talk about domain and range, domain will be x, range will be the y values. You also will see the words independent variable and an input for domain, and dependent variable and output for your range. Okay, now first off, when it says evaluating a function, so f of x is just a fancy way to write y. So we are saying y equals 3x squared plus x minus 5 is our equation. So if I want to figure out what my answer is going to be, we are plugging in for a -2 wherever we see an x in our function. So we're going to write it as 3 times -2 squared plus -2 minus 5. So you're just going to type that into your calculator. So when I type it in, that will give me what my answer should be. I'm not going to use the calculator on my desktop right now. That's going to be for later on. It just takes me a while to type everything into that calculator. So you type it into your calculator, or I'll type it in on my handheld calculator. When you type it in, you should get 5 for your answer. Doing the same thing with 0. So wherever there's an x, we're going to put 0 now. So when we do that and plug that into our calculator, we're going to get a -5. Same thing for 4. Put 4 in for x now. If it gets confusing as to what you're supposed to plug in, just think wherever the x's are, it's like saying parentheses. We're dropping in whatever number you have in parentheses in for our x. So when I do that, I get 47. And we put 1/2 in. We're going to get a decimal. And remember, WebAssign doesn't like decimals unless they're decimals that stop. So because it's -3.75, it is a decimal that stops. So you could write it in decimal form. So if it says evaluate, all you're doing is plugging it in. Now for example 2, we're going to look at piecewise defined functions. Piecewise defined functions give you multiple equations. You've got to figure out what equation that you're going to use. So for A, we have -5. You've got to figure out which one of these 3 -5 is going to fit in. So you're not looking at your equations, you're looking at the if parts. So -5 would be less than 0. Because -5 is less than 0, I use the first equation. So again, you are seeing where that number falls in the 3 parts with your x's. So I want to put -5 in my first equation, and I should get -15. Next, they have 0. Now with this, it makes it a little bit harder because you have 0 with no equals, and here I have 0 with an equals. So if I'm trying to figure out the one that 0 falls in, I want the one that has the 0 with the equals, because that means I have that 0 included in that group. The other one, the 0, is not included in that group. So for part B, you're going to put 0 into the second equation. Then for part C, I've got 1. So you've got to figure out which one of our 3 that 1 would fall into. Since 1 is between 0 and 2, 1 falls into the second equation. Then for D, we have 2. So again, same thing. You've got to see where 2 is. Since 2 has the equals for the second equation, 2 goes with the second equation, not the third equation. So we would put 2 into the second equation. Then the last one's 5. So when x is 5, 5 fits into the last equation because 5 is bigger than 2. So if I plug that in, I've got 5 minus 2 squared, which will give me 9. So make sure that you look at the if parts here with your x's, because all of these numbers here that are listed in parentheses are your x values. So you want to see which one of the 3 the x values are going to fall into. Now example 3 is going to be a little bit harder as we go through this. So now we're replacing our x values with letters. So for part A, we are putting in A wherever we see an x. Whereas before, we put in numbers wherever we saw an x. So wherever you see an x in our equation, put an A. So that means we'd have 2a squared plus 3a minus 1. Now for part B, we're putting negative a in. So when you put negative a, you need parentheses around it. And then we need to simplify it. So if I square negative a, that's going to be a positive a squared. 3 times negative a is minus 3a, and then minus 1. Now for part C, we're putting in a plus h. So that whole chunk has to go in for every single x. It's going to be a lot more math that we're going to have to do too. So we've got there we go. So wherever you see an x, I have to put a plus h. Now we've got to simplify. Remember, a plus h squared means there are 2 of them. So you cannot say it's a squared plus h squared. So if you want to, you could multiply your a plus h's together first, and then multiply by 2. And then you want to combine all your like terms. So that is my answer for part C, that last line there. I need to split this because this is going to be longer for part D also. Now, for part D, we are plugging in our information into this fraction. So you're taking your answer from C, because that's f of a plus h, and you're going to subtract your answer from A, because that's f of a, and then we're going to divide it by h. So again, take your answer from C, and then minus your answer from A, and then divide it by h. And again, I've got to write small so I can squeeze it all in. and then minus. Now when you subtract, you've got to put parentheses around your chunks, because when you're subtracting two things, that minus has to go into every part. That does say 2a squared plus 3a minus 1. And then you're dividing everything by h. So now on top, you have to distribute that negative through to each of your parts. So when I do that, then we've got my whole slew again. And again, that's all over h. I'm just running out of space. I write bigger on my smartboard than I do on my handout. Now, if you look, though, you're going to have some opposites. We have a positive 3a and a negative 3a. I've got a positive 2a squared and a negative 2a squared. We've got a minus 1 and a plus 1. So we're canceling out a lot of stuff. So the only parts that are left are 4ah, 2h squared, 3h, all over h. The last thing we're going to do is simplify. So since each of those on top have at least one h, we can divide everything top and bottom by h. So for my final answer, it would be 4a plus 2h plus 3. You have one or two of those on webassign. So again, if you struggle with going through that, just let me know. We can look at problems together if you go through them and want some help. The last part of this section is domain. Domain is the set of all the numbers where the function is defined. It's your x values. Now, here at the high school, one of our teachers explains it this way with this little chart here. And I think it does kind of help. If you have something in the bottom of the fraction, the bottom can never be equal to 0 because it's undefined if you have a 0 in your denominator. If you have a square root, you have to have a number that's greater than or equal to 0 because you can't take square roots of negative numbers. Last one then, we've got a radical in the bottom. If it's in the bottom, it has to be greater than 0. Because if your bottom is equal to 0, it's undefined, like I just said for the last one. So again, it has to be greater than 0 if you have a radical in the bottom of the fraction. Now, going through these, it might be easier if you visualize what's going on, which is why I have the calculator up there for you. So if you visualize, you can see on your graph what's going on. And it might help you see what x can't be equal to, what x can be equal to, and all that. So I tell my students to graph it so you can see what your graph looks like. So we're going to graph A. So you're going to go to your y equals, clear out anything that's on. Now I have to go and turn my plot off because I was doing statistics, and so you should not have any of the plot 1, plot 2, plot 3 dark. It should look exactly like this right now. So now when we type this in, it's going to be 1 divided by parentheses, and then we want x squared minus x. And then end your parenthesis. Now you're going to hit graph. Remember, if you're looking at your graph and you cannot see anything, what you want to hit is your zoom number 6. Because if you share your calculator, or if anybody else has used your calculator before, it might not be in the correct viewing window for you. So zoom 6 always brings you back to the normal screen. Now if we look at our picture here, we are seeing that there is no graph really right here, and there's no graph really right here. because this is going to continue to go straight up. This is going straight down, and then this one goes up. So we have some jumps in our graph. Whenever we have jumps in our graph, that's where x can't be equal. So if you look at the bottom of your fraction here, and I set this bottom equal to 0, I factor out the x, and this tells me the bottom is equal to 0 at 0 and at 1. And if you look at your picture here, at 0 and 1, we are jumping from different graph to different graph. That tells me x can't be 0, x can't be 1, because we are undefined there. If I put those into my equation, that's going to give me a 0 in the bottom. So we know that x cannot be equal to those numbers. It can be anything else but those numbers. Now we have to write this for WebAssign. WebAssign is going to want an interval notation. So if I write this in interval notation, we have to say everything x can be. So we want negative infinity up to 0, 0 to 1, and then 1 to infinity. We write those with parentheses because we can't include them. Bracket would be we can include the numbers. However, I can't put 0 and 1 in my function, or that's going to tell me doesn't exist. Doing the same thing for b. So I'm going to put that into my y equals. And then hit graph. Now this one's a little easier to see. If you look at your picture is only going from -3 to 3 on the x-axis. There is nothing else out there that it is hitting. It's kind of half a circle here. Now you've got to figure out if -3 and 3 actually work with the problem. So you have to put -3 in for x and see if we actually get a number on our calculator. So when I say put it in, you're plugging it into your calculator. So if you need me to show you, again, hit clear, do second square root, 9 minus parentheses -3 squared, hit enter. Since I get a number and I don't get an error on my calculator, that tells me that -3 is included in my answer. I can do the same thing with 3. That also has 0. So that means I can include those numbers in my answer. Because again, if you get an actual number on your calculator, that works. If you type it in and you get an error on your calculator, it's telling you it doesn't work. So then it's undefined at that part. So if I want to write this, I'm saying I want every number between -3 and 3. So to write that in interval notation, I would do bracket 3 to bracket 3. So -3 to 3 for my brackets. Again, if you have an equal sign saying you can be equal to those numbers, you're going to have a bracket for your interval notation. Now for our last one. Again, go to your y equals, clear out what you got. So I've got x divided by square root x plus 1, hit graph. Now if we look at our picture here, this is showing on our graph we want everything from -1 to the right. So I want everything my blue line covers because that's your domain. That's your x values. So if I want to start at -1, I've got to figure out if -1 works. So I'm going to clear my screen because again, -1 is where we're starting at right here. Clear my screen. And I'm going to do -1 divided by square root -1 plus 1. Now, if you see it comes up with an error, so if it pops up with an error saying you're dividing by 0, we can't put -1 into the problem. Because if you put -1 in, you're going to get a 0 in your denominator. So we can't do that. So when I write my answer, I need to make sure that I don't include -1. So we are saying it has to be everything greater than -1. And I write that interval notation as -1 to infinity. I've got a few here for you to try. Okay, so again, hit pause if you want to hit pause. So for the first one, we are plugging in 1/4. So I have 1 minus 4 times a fourth. So now you're just simplifying. If I type that in, 4 times a fourth is 1. So that's 0 over 15. You can actually do 0 divided by 15 on your calculator. So my answer would be 0. Now for a minus 1, I have to do 1 minus 4 and put a minus 1 in for x. So we want to distribute that -4 through. So combine your like terms. I've got a minus 4a plus 5 all over 15. So you're not going to get an a equals a number when you have letters in there. When you have letters, you're going to have letters in your answer. So don't think you have to have a number answer for everything. Same thing for the second one here. Hit pause, come back to me. Okay, so our function is -x squared minus 7x plus 8. We have to put square root of 7 in for x. Now that minus sign is not a part of your square. The minus is in front. So it says square your number, then take the minus with it. So you're not saying my answer is going to be a positive number. Your answer will be a negative number when you square that. So square your radical 7. Again, when you square a square root, you just get the inside. Then we have 7 times the square root of 7. We can't multiply those together, so the only way to write it is 7 square root of 7. And then we're going to add 8 to it. So combine your like terms there. And we should have 1 minus 7 radical 7. Again, I know it looks weird because you want to have a decimal, but we have to have exact answers. There should be no decimals when you go through that with radicals. Now for -x, this is a little bit more confusing. The negative outside of your x squared stays in front. Then you have to put parentheses around your -x, square that, minus 7 times -x plus 8. So if I square my -x, that becomes a positive x squared. But because of the minus in front, it's going to be minus x squared. Then we've got minus 7 times minus x, so plus 7x, and then plus 8. Last one then, domain. So like I said, it's easiest if you put it into your calculator. So we're going to go to our y equals. We're going to clear out what we got. Square root x squared minus 16. Now you're going to hit graph and you're going to look at your picture. Now, if you look at your picture, it's saying we're getting really close to -4, then we're stopping, and then we're going to go from 4 to infinity. So they want everything beside what's between -4 to 4. But remember what I said. We've got to check to see if -4 and 4 actually work in our problem. So we could do this by hand also. If I do 1 over square root -4 squared minus 16. Well, if you square -4, you get 16. So 1 over square root of 16 minus 16 is 0. So 16 minus 16 is 0, and I get 1 over the square root of 0. Well, we just said you can't do a square root of 0 or 0, anything with 0 in the bottom, because the square root of 0 is 0. So that means I have an undefined at -4 because I have 0 in the bottom of my fraction. If I put the +4 in, +4 squared also gives me 16. So I would also get 0 on the bottom. So remember what I told you. We can't include -4 and 4 then. So what we're saying is x has to be everything smaller than -4, or x has to be everything bigger than +4. Because if you look at your picture, it's everything left and right. So if I want to write that interval notation, -infinity to -4, and then 4 to infinity. I have those little u's there because they mean or. So you're just saying I want that group or I want that group when you write it. So again, if you have questions over 2.1, feel free to ask me. Shoot me questions on WebAssign if you got them too, and we can go over any questions you got too on Tuesday. So we will have time to look over things if we need to go over anything together.